The Theory of Political Economy by William Stanley Jevons. Chapter 6 Theory of Rent. Part 2 Symbolic Statement of the Theory. The accepted theory of rent as given above needs little or no alteration to adapt it to expression in mathematical symbols. For doses or increments of capital I shall substitute increments of labor, partly because the functions of capital remain to be considered in the next chapter, and partly because James Mill, John Stuart Mill, and McCulloch hold the application of capital to be synonymous with the application of labor. This assumption is implied in James Mill's statement. It is expressly stated in John Stuart Mill's first fundamental proposition concerning the nature of capital, and McCulloch adds a footnote to make it clear that as all capital was originally produced by labor, the application of additional capital is the application of additional labor. Either the one phrase or the other may be used indiscriminately. This doctrine is in itself altogether erroneous, but it will not be erroneous to assume as a mode of simplifying the problem that the increments of labor applied are equally assisted by capital. It is a separate and subsequent problem to determine how rent or interest arises when the same labor is assisted by different quantities of capital. I shall suppose that a certain laborer, or what comes to exactly the same thing, a body of laborers, expend labor on several different pieces of ground. On what principle will they distribute their labor between the several pieces? Let us imagine that a certain amount has been spent upon each, and that another small portion, delta L, is going to be applied. Let there be two pieces of land, and let delta x1 and delta x2 be the increments of produce to be expected from the pieces respectively. They will naturally apply the labor to the land which yields the greatest result. So long as there is any advantage in one use of labor over another, the most advantageous will certainly be adopted. Therefore, when they are perfectly satisfied with the distribution made, the increment of produce to the same labor will be equal in each case. Or we have delta x1 equals delta x2. To attain scientific accuracy we must decrease the increments infinitely, and then we obtain the equation dx1 over dl equals dx2 over dl. Now dx over dl represents the ratio of produce, or the productiveness of labor as regards the last increment of labor applied. We may say, then, that whenever a laborer or body of laborers distribute their labor over pieces of land with perfect economy, the final ratios of produce to labor will be equal. We may now take into account the general law, that when more and more labor is applied to the same piece of land, the produce ultimately does not increase proportionately to the labor. This means that the function dx over dl diminishes without limit towards zero after x has passed a certain quantity. The whole produce of a piece of land is x, the whole labor spent upon it is L, and x varies in some way as L varies, never decreasing when L increases. We may say then that x is a function of L. Let us call it PL. When a little more labor is expended, the increment of produce dx is dPL, and dPL over dl is the final rate of production, the same as was previously denoted by dx1 over dl. In the theory of labor it was shown that no increment of labor would be expended unless there was sufficient recompense in the produce, but that laborer would be expected up to the point at which the increment of utility exactly equals the increment of pain incurred in acquiring it. Here we find an exact definition of the amount of labor which we profitably applied. It was also shown that the last increment of labor is the most painful, so that if a person is recompensed for the last increment of labor which he applies to land by the rate of production dx over dl, it follows that all the labor he applies might be recompensed sufficiently at the same rate. The whole labor is L, so that if the recompense were equal over the whole the result would be L multiplied by dx over dl. Consequently he obtains more than the necessary return to labor by the amount PL minus L multiplied by dx over dl, or, as we may write it, PL minus L multiplied by P prime L, in which P prime L is the differential coefficient of PL, or the final rate of production. This expression represents the advantage he derives from the possession of land in affording him more profit than other methods of employing his labor. It is therefore the rent which he would ask before yielding it up to another person, or equally the rent which he would be able and willing to pay if hiring it from another. The same considerations apply to every piece of land cultivated. When the same person or body of laborers cultivate several pieces, P'(L) will be the same magnitude in each case, but the quantities of labor, and possibly the functions of labor, will be different. Thus with two pieces of land the rent may be represented as P1L1 plus P2L2 minus L1 plus L2 P1'L1. Or, speaking generally of any number of pieces, it is the sum of the quantities of the form PL minus the sum of the quantities of the form L multiplied by P'(L).